In this lesson, we'll learn about 3ds Max's history independent, history dependent, and IK limb solvers. There are various types of IK solutions in 3ds Max. We find them under our animation menu, IK solvers, and what we'll take a look at are the first three. We'll spend a lesson on the Spline IK solver, which is another really neat solution that gives us a lot of flexibility. Now, before we start to work with these, let's first understand what inverse kinematics is. Now, if you've heard of forward kinematics, you know that it's simply just a matter of rotating bones down a hierarchy and animating that rotation. Now, inverse kinematics will inverse the rotation of our bone objects as they follow an IK goal or end effector. So let's go ahead and start to work with each of these solvers now to take a look at their similarities and differences. So starting at the top with the history independent solver, we'll make sure that we have our root bone selected, and now we'll go ahead and connect this to our nub. Alright, so let's take a look. As we start to move this around, you can see that the bone objects are inversed again to follow this IK goal, also known as an end effector. This is very useful for animating limbs, so your arms and legs. You could also use this to animate insect legs. But to get more creative, you can integrate this into your character's finger rig so that the finger can remain planted while the root moves, in case, again, the finger needs to have some type of pressure on a surface. You can go ahead and work with this type of rig. So this is really neat. Now, some other features we have, if we were to go ahead and scroll down in our motion panel until we find our IK solver properties, is we could go in and start to adjust the twist disk of the solver, which is useful for animating knees and elbows. Now, if I were to go ahead and just right-click on this parameter to zero it out, let's go ahead and take a look at what happens when we try to rotate our root or any bone in this chain. It's not going to happen because the rotation has been locked down. Something also to keep in mind is that when it comes to the root of this IK system, you can see that it has much more freedom when it comes to rotation. It can rotate in any direction. However, the child objects, they only have 1 degree of rotation, and that's in the bend direction. All right, so that's just something to keep in mind. Now, going back to our IK solver properties, take a look here. Instead of using this swivel parameter, we can assign an object to control the swiveling of this system. So let's go ahead and experiment with this. If we were to go to our create panel and create a point helper, let's now use Shift A to quick align this to the second bone in this chain. And we want to move it away. If it's too close, we can run into flipping very easily. So we want a little bit of space here. But now we can go back to our IK goal, go to our motion panel, and let's go ahead and choose our point helper as the target. Alright, so let's take a look. Now when we go to our point helper and start to move this around, you can see that now we're controlling the twisting of this chain from this object that the chain is pointing at now. Which is great because that means we have much more control over deciding where the knee or elbow should point. If it needs to be locked down to a certain spot, we have that control now. Now, if we wanted to turn this off, we can go ahead and turn off use here. And now you can see that the system will revert back to looking at the value of the swivel parameter. When we turn back on use, it points back at the object we've assigned. Alright, so that's a look at our history independent solver, primarily used for animating limbs. Now, I'd like to point out that when we go to our IK goal and start to move this, you can see that eventually we will run into flipping because now the chain is pointing at this target object. So, to fix this, it'd just be a matter of taking the target and moving that to fix the flipping. Alright, it's really straightforward. Now, another idea would be to create an IK control and then parent the target object to that control so that as the control moves, this follows, and that will also help you to prevent flipping. You still will need to move this target object, but that will help you to fix flipping issues a lot faster. Now, we wouldn't want to take this helper here and parent it to our IK goal. You can see we're going to run into a dependency loop because this helper is influencing this system. Okay, we've assigned it to be a target object. So instead, what we'd want to do is create another object as a control. I'll create another point helper. After right-clicking to exit the tool, we can now go to our Modify panel. Let's go ahead and make this a box instead of cross, just so it's easier to select. And now we can go ahead and quick align this with Shift-A to our IK goal. We can grab our link tool, and now we can link our goal to the new helper. And then we could also safely take our target object and have that linked to our helper as well. So let's take a look as we start to move this control around. Notice we have a greater range before we run into flipping. Eventually we will as that helper starts to get away. But once we start to bring it back, that will fix the flipping issue. Alright, so I wanted to point that out to you. Alright, so now the next solver we'll take a look at is another way we can animate our limbs, only it is a bit limited. So let's go ahead and take a look at that. We'll go ahead and grab our next root, and we're going to skip over the history dependent solver. We'll save that as the last topic we cover in this lesson. But let's go ahead and grab the IK limb solver, and we'll connect from the root. Watch what happens when we try to connect to the nub. You can see that that's not going to happen because this solver is used for two bone systems. So that's why this would be great to animate limbs, hence the name. So we could use this for our arms and elbows, and it has the same features the history independent solver has, only, again, we connect to two bones with this one as opposed to the history independent solver that can be used for multiple bones. That's why this one would be great for animating insect legs, whereas the IK limb solver would be great to use for arms and legs. Alright, so that's essentially, again, a look at the IK limb solver. Notice we have the same features. We have a twist disc here, and we can also assign objects the same way to control the swiveling of this system. Now the last one we'll take a look at is a bit more complex. It's primarily used to animate machinery and parts that would resemble the machinery components that we would need to animate. If we were to go ahead and select our root and choose the history dependent solver, let's go ahead and apply this to our nub and take a look at what happens. Notice a goal or effector has been applied to each section. Now before we go in and start to tinker with any of these, we first need to set a few things up in our motion panel. So starting with the root, let's go ahead and make sure that that object is selected just to kind of refresh things. And what we'll do is go ahead and apply a rotation end effector, not the position, we'll leave the position alone. But for the next one, we will apply a position and rotation effector. So after the position has been applied, we'll go ahead and take care of rotation. We'll go to the next bone and do the same thing, position and rotation. And then for our nub, with that selected, we'll just worry about position. That's already taken care of. We won't apply rotation, just to take a look at what happens. Alright, so now let's take a look. When we go to our root here, so we start to move this around, you could see how the chain will react, how it behaves. So it's a bit constrained, but you could see how this would be useful for machinery or some type of robotic mechanism. When we try to rotate, notice we can control the twisting of this chain, but it is very restricted. If we were to, with that same bone selected, go back and delete the rotation effector, you can see that now we no longer can twist this, but we can safely go in and start to move this around. If we were to go ahead and apply a position effector, that's going to lock this root down. That's exactly why we didn't apply it. But if we were to go to the other objects that we applied both a position and rotation effector to, you can see how much flexibility we have. So it's a really neat solver once we start to understand how it works. But we wouldn't necessarily want to use this for characters unless they had some robotic parts to them. When we go to our end nub here and we start to move this around, you can see again it's influencing the entire chain. When we try to rotate, we're going to get none of that because, of course, the rotation effector has not been applied. So I just wanted to give you some ideas of how this system can be used. So again, that's a look at the first three solvers in Max, our history independent, history dependent, and IK-lim solvers. We learned that the history independent solver would be very useful for animating limbs, including insect limbs. The history dependent solver would be good for machinery, and our IK-lim solver would be used for just animating arms and legs of, let's say, a biped. We may also be able to use this for quadrupeds as well. But chances are, for creatures, you'll stick with the history independent solver because it has a lot more flexibility and options.